Hello, thank you for joining us this morning for the first in our series of law enforcement briefings from Bedrock. This is a new series of webinars that we're running specifically for people who work in police or law enforcement roles who want to learn more about some of the technology that Bedrock implements and supports. Just a bit of housekeeping before we start, and I hand over to our technical expert. Don't feel like you need to frantically take any notes while you're watching this, as we will be sending out a recording to everyone who's registered. So you'll have that as a follow-up later today. Also, if you have any questions you'd like to ask at any point, please do feel free to drop those into the Q&A box, and there will also be dedicated time for questions at the end of the webinar. So let's take a quick look at the agenda for today. I'm just going to give you a really quick introduction to Bedrock for those of you who may not know so much about us at the moment, an overview of SD-WAN and how it works. We'll take a look at some real-world use cases for SD-WAN technology, and then Michael will be introducing how we can implement some of that SD-WAN technology into your networks. Following that, like I said, there will be opportunity for some Q&A and the next steps of what you can do. So let's start with the welcome. My name is Jennifer Benge and I'm the marketing manager at Bedrock. You'll be pleased to hear I'm not doing the technical aspects of today's webinar. We will be joined by Michael Crabtree. He is a senior technical architect at Bedrock. So he'll be talking you through all of the nitty-gritty of the SD-WAN. Bedrock itself is an IT managed service provider and a Microsoft Gold partner. We also work with some of the most highest security requirement organisations within the UK. We're experts in secure, resilient networks and managed IT solutions where high performance is absolutely critical. So like I said, this includes law enforcement organisations, also some critical national infrastructure as well. So we work with companies who really absolutely need their IT and all of their tech to work at every moment. So, Michael, I'm going to hand over to you now. Hello, Michael Crabtree.
Yeah, hi, everybody. I'm Michael. As Jenny said, senior technical architect. So some people will remember me into dealing with a lot of projects for yourselves or working a lot alongside some of the technical things that we've delivered for you all. These days, I deal more with try to understand what problems you have and what solutions we can work with you on to fix those problems. So yeah, so we're going to make a start. We're going to start off by having a little look at what is SD-WAN. So what is it? So basically it's the ability to use available WAN services and to be able to use those more effectively and economically to provide redundancy, to provide load balancing, to provide traffic optimization or prioritization, and we'll talk about why that's really important later. It can also be used to create a scalable installation that can grow as your operational requirements and maybe the timelines of your operations may change. So if we have a look at how it works. So SD-WAN works by routing different applications and different types of data over the most efficient WAN connections at any point in time. So to do that, it's got to be able to identify a broad range of data types and different applications. It's got to have an awareness of the quality of a WAN connection with strict SLAs that monitor jitter, packet loss, and latency. And it's also got to be able to apply effective rules and policies based on that information to reduce the downtime and to reduce any system outages that you may have. So why would you choose SD-WAN? If we have a look at some of the other technologies that you may be used to using, then we can make some comparisons. So things like the 4G, 5G routers that some people use, some of those will be dual SIM, but they will only use the second SIM in the event that the first one either completely fails, just simply stops working, has no signal at all, that type of thing. And what would happen is, even if that's first SIM is got a really bad signal, it will still continue to use that SIM. They can't load balance, so they can't use both those SIMs at the same time. Certainly not in an environment that you can, using them encrypted with VPNs, etc. Sometimes the operating systems and firmware are based on either freeware or accessible kind of types of firmware or freeware, that type of stuff, open source type stuff. So people can have a look at that, work out where bugs are, and take advantage of that. They can't differentiate between traffic, different types of traffic, or implement any type of bandwidth control, which again, when we talk about how you implement some of this stuff, is really important. With a firewall that can do SD-WAN, we can do dual SIM. We can actually do a lot more than that. We can have lots of different types of WAN connectivity, and we can certainly do more than 2 if required. They can support multiple bearers, as I just said. They can do load balancing if required. So if you've got lots of cameras, you can send maybe 1 or 2 down one connection and maybe send another couple down another at the same time. The operating systems and firmware are built fundamentally to be secure, and some of these can have certain compliances with people like NIST and all that type of thing. They can differentiate and prioritize traffic, and we can do bandwidth control as well. And when you've got different types of internet connections or WANs, then that's really important. So if we take a deeper dive into what that might look like, this is an example of a device. And as you can see, we're monitoring packet loss, latency and jitter, and we can see some charts that were taken in real time off these devices. If we have a look at the bottom there, we can see that this particular device had 4 connections. So we can see that it's got 2 FTTCs. It's got a WISP, so that's a wireless internet service provider. It's also got a 4G router attached as well. And you can see it's monitored all 4 of those, and we can see packet loss to them all is 0 in this case. The latency, we can see some of have got more delay than others. Funny enough, the 4G is probably the worst there. And then we can also monitor jitter as well, which is also really important. And maybe you guys don't do any VoIP services, but we know that some voice services really don't like changes in latency and jitter. So it's really important to understand that. So yeah, a next-gen firewall can monitor all of this at once, and it can use that against the metrics that we looked at. So if we take a look at SD-WAN rules, so based on that monitoring, we can create rules. This probably doesn't really have the types of things that you guys will use, but it's not a bad example, and we'll have a look at some real examples out of a device shortly. So we can see the rules, and in the case of the one at the top there, we can see there's a rule that says Gmail. It's set up to be able to use both WAN 1 and WAN 2, and we can see that with the flow in place, that it can go out of those 2. And this doesn't really specify whether or not they're done as load balancing, whether they're done as a primary or a backup, but essentially it can make decisions based on the metrics in terms of which one to use. Without any further changes, it will often use the top one, and we'll see that in a minute. So if we have a look at a bit more detail at some of those rules, the rules allow different data types to essentially be channeled down different WAN connections or use different combinations of WANs. And I'm going to show you a couple of rules a bit further down here. So in this example, we've got a VoIP rule, and we can see that is triggered against SLA. It just says SLA. We'll look at that in a minute. And we can see that it's going to prefer the first FTTC connection, and then the FTTC2 with the second one will be used as the secondary. So if the first one fails the SLA, it will use the second one. We do have a generic packet loss rule. That's for internet in this case. And again, we've got all 4 of our connections here. So we've got the FTTC, the second one, WISP, and then finally the 4G. And that one is just used for internet in the case of this one. So if we have a look at some of the SLAs. So the SLAs themselves are used to set thresholds of which a WAN will be considered out of service. So the firewall essentially rules it out for use. If any of those metrics go higher than the set values, then the WAN is put out of service, and then it'll just use the next one in sequence. So in the example here, we've got them ordered as WAN 5 for the WISP, and then finally that 4G, and it will use them in that order. And you can see in the example on the right there, we've got the latency thresholds and jitter, etc. When you're setting these, you really must set them based on the worst internet connection you've got, or the worst one you've got. FTTC, we all nominally 20, 30, 40 milliseconds. That's the type of thing you'd expect out of some of those. 21, 22 is nominal. But you can see we've got 500 here. If we set that to 100 milliseconds, there's a fair chance that the 4G will always be out of service, because they will often be 100, 150 milliseconds nominally, and based on the data going through them, they can go up and down quite a lot. So from this, we obviously monitored this, noticed that sometimes 400 or so could be what that goes to. So in this example, we set it to 500. We noticed the jitter went up and down a bit, so we've set that. And then the packet loss, really don't want much packet loss. So that's still quite low at 5%. So we had to tweak this based on the worst internet connection we had in our stack of internet connections or ones that we've got. Also, we want to make sure that flapping doesn't occur, whereby if the main connection has a problem and it uses the backup connection, then we don't want it to suddenly start flapping backwards and forwards if the primary suddenly gets connected again. We want it to have a smoother transition and make sure that primary is working effectively first. So the link status part of that, we're checking every 500 milliseconds for the status. And we want to make sure that we've got 5 failures before we transition over to the backup. And then we want to make sure we've got 5 good link connections that have been checked before it reverts back to the primary again. Sometimes we may tweak that depending on the connections, but generally what it's got set there is about where we'd expect to be. So with this type of technology, there's some things that people say, well, actually, doesn't this need like big IT hardware, lots of big firewalls that you need in a rack? Because most of the time, these things are big, they're noisy, they use lots of power and generate lots of heat. And that's no good for the types of environments you work in. So yeah, it's a good opportunity to introduce you to something like this little box here, which is from Fortinet. It's one of their 30Ds, because you need something that's compact, preferably rugged, quiet, or hopefully fanless, so it's silent. Works in wide operating temperatures, hopefully wide voltages, so it can use your batteries and all those types of things that you guys will use. Hopefully some low current consumption, so it doesn't waste a battery really quickly. And preferably dual input, so you could put in a battery and you could put AC on there as well, so you can use both. And these guys fulfill that. These are 12 to 24 volts, so they'll take most types of batteries. They're just over an amp of consumption. They've got a really wide operating temperature, -40 to +70. And again, they've got dual power. Very small, 4 ports, a couple of fibers if you're going to use them. But they're a great little device. If you need something a bit bigger with a few more ports, there is another rugged device that Fortinet do as well. It's the 60F rugged. These are what's called a 61850 compliant, so which means they'll work in substations and all sorts of stuff, which I know you guys don't work in, but it's pretty much the most hostile type environments that these type of stuff have to deal with. So very wide ranging voltages of 12 volts right up to 125 volts DC, and it'll take both negative and positive grounds as well. 2 amps of power consumption, a little bit more, but still pretty good. -40 to +75 degrees operating temperature, and these can have 4G built in. They can take a SIM card as well, so you can use that alongside maybe a 4 or 5G modem. They are 4G at the moment. You do find that with these types of devices, and this goes the same across the board really, you'll find that they can be a little bit slower just because of the amount of work and compliancy and all the things that they have to do to make sure that whatever modem they're putting in is going to work effectively with their system. So they are 4G at the moment. If you need PoE, so you want to power your cameras off these types of devices, then you're looking more like their more standard range. I've included one just to show you the differences in the way that they function. 12 volt DC, which is pretty good actually for something that's doing PoE, because normally you have to try and find a weird 48 volt power supply from somewhere. Bit more power consumption, as you might imagine, and you'll need to add on other power ratings for your cameras, you know, typically 15 watts, 7 watts, whatever it is per camera. A more normal 0 to 40 degree operating temperature, but they do have 8 PoE plus ports, which is great, so you can power your cameras off them. So if we have a look at an example of this in use, so what we've got here is a system. We're going to use Milestone because it's not a bad example. I know a lot of people use it, so it's quite a good example of using SD-WAN technology and the types of things that would go on it. So we've got 2 locations. We've got a primary and a backup location. And in this example, we've got fiber broadband, we've got 4 and 5G, and we've got a pretty good internet as well. So we've got 3 connections on these, and we can see we've got Milestone recorders at both sides. We've got Milestone clients at both sides, and then we've got a front end location, or an example of one. In this example, we've got 3 connections on that potentially as well. I'll say potentially because I'm going to explain in saying the tips and tricks about why that can be good. So we can connect multiple VPNs. The 2 main differences between this example and maybe some of the others I showed you before, which were mainly just going out to the internet for World Wide Web and VoIP, main differences are we take the VPNs that are created, we add them into SD-WAN, and then we create policies against them. And that's how we will do it. So yeah, in the same way as we added all of the internets, the WANs into SD-WAN, we add our VPN tunnels into SD-WAN. And then we can do very similar things, which is great. So yeah, with that, we can create the different VPNs. So yeah, we may create 3 or 4 VPNs or wherever it is, say 3 VPNs from the front end to the backup, to the primary, sorry. And then we will create another 3 VPNs from the front end location to our secondary backup location. So we'll do that. The other thing that's on here is traffic control as well, and traffic shaping. The reason we're doing that is that different internets that you've got will probably have different bandwidths associated with them, and therefore you may need to control your bandwidth. The other thing is also to do things such as traffic prioritization. As we said already, you know, there's certain data types you may want to protect. Yeah, and people will often think, oh yeah, I want the video to get through. Yeah, definitely need the video to get through. However, with something like Milestone, really important the management gets through, because if you don't, if there's no management connection, then Milestone will probably just drop the stream because he's not communicating with the camera, so he'll just drop it. And if you need to make changes to those camera settings, and if you need to make sure you can manage it, then you're going to have problems. You'll put it in, the camera will come up, the video will start streaming, and if it needs changes making, or you need to make sure that that video is running at the right speeds, you're going to find it very difficult to make those changes because all of your data pipe is swamped by the camera's video. So we can do prioritization, prioritize that Milestone traffic, make sure that gets through, and then if we want to, we can then traffic shape the video. So in this example, you know, with a really good internet, then we can have all the cameras streaming live. The management data is getting through, but is prioritized just in case. If we drop down to a lower internet, then we would still prioritize that management traffic, but we may also limit the camera traffic just to make sure it doesn't swamp that internet. And then if we go down to, say, a really low level SIM card, I do remember SIM broadband, SIM bandwidth is variable. You're not guaranteed to have the same every time, and certainly times of day as well. So what you can do then is you can limit that, and then you would obviously need to just make sure that your camera is set, and we're going to look at that in the tips and tricks, is set to the correct level so that the video will pass cleanly. So if you have a look at another example, so this one here is another example for another customer, which is where we have offset all of the main management and security services and recording services and other sorts of things into a data center. For this customer, we've put it into 2 data centers, which we host. We've currently got them going through PASF, which is the police approved secure facility. certification for our data centers, which is fantastic. So we'll be cleared to house this information and equipment for people. So we've got redundant firewalls, we've got our recorders, our failover recorders, in this case milestone management services. We've got our security services, such as, you know, virus protection, Windows updates, all that stuff is all housed there. Because it's a data center, we can have really good lease lines and internet connections, and we can have multiple lease lines and internet connections, you know, at gigabit per second type connections out of a data center. So we can do that, and then we can have separate operations centers that are then connected into that for viewing video. Again, our front end, maybe quite a small deployment with a small covert camera or something like that, maybe with a couple of 5G bearers. As I say, this is an example, so you know, you can fit whatever you like in terms of those connections. And we've also got, you know, because it's all now decentralized, so to speak, in that respect, we can add things like temporary operations rooms relatively easily. So the same concepts around an SD-WAN configured front end can also be made for an SD-WAN configured back end or ops room, or whatever you want to call it. You know, that maybe one of your operations teams is doing an op for 6 months or a winter, whatever the time frame is, and you want to put them in a client, put in a firewall, get a connection, however that method is, you know, whether that's for fiber or whether that's maybe even your Force IT can provide you some connectivity through their networks. We know some customers do that. And be able to make a connection that way, and have your temporary operations room, so to speak, be as versatile as your front ends. So let's have a look at an SD-WAN deployment. So a couple of tips that I've got into for people who are looking at deploying this type of thing is create an inventory of pre-configured firewalls. This is a great way of having things to hand that you can use and build a lot of versatility into this. Because obviously as people look at it, I think, gosh, there's lots to configure, there's lots to consider. Do I need to sit and configure this device and build this device every time I want to deploy something? No, you don't, not at all. You can pre-configure all of your connections for your cameras / clients. So whether that's going to be a front end or whether that's going to be this temporary op room. You can pre-configure some ports for your internet or WANs. In this example, we had 3 and we can do 3. Just bear in mind with something like a FortiGate that the name on the port doesn't have to be what it says. That's more of a, you know, commercial / marketing or whatever you want to call it. You know, it's people are used to seeing those things in a commercial world, and therefore they've decided to put them on. So in our case, the one that's called DMZ, we've given, you know, we're not using it as that, we're using it as an internet. So we can create our 3 WANs. Maybe they've just got DHCP on them, so that as soon as you plug it into a router, it will then just pick up an IP address, get out to the internet, nail up the VPN, and then off it goes. Also, because you've done that, use the most appropriate port for the WAN that you're going to use. We've got some people who've labeled up those ports as, you know, one of us as fiber broadband, one as 5G, so that in this example here, if you only had FTTC and 5G, then you would use your WAN 2 and WAN 3 and you would plug your devices into there, knowing that the configuration is going to be, you know, quite a way on without you doing anything. If you don't plug anything in and it doesn't get an internet connection, it doesn't use it. So it's a real kind of versatile way of using these boxes. Understand the settings on your camera to ensure they're fit for the deployment. As we said, we can do things like traffic shaping, we can do things like prioritization, but making sure your cameras fit the deployment. Consider that resolution, frame rate, and that bandwidth, just to make sure they're fit for what you're doing. You may start off reserved, do some checks. Some people may actually do some speed tests as well to get an idea of what that bandwidth feels like. And then you can always bring that up as you do checks and you find out how good your internet or your 5G is. Also, think that you can basically tweak a lot of your traffic shaping as well. So when you put them in, you've connected up your internets. If you've got 5G, you could probably sit and do that on the desk. And you can also tweak your traffic shaping as well. So you may go, oh, actually, I've put in this this internet, it's giving me 20-30 meg upload, then I'll just tweak my traffic shaping. And it's really, really easy to do because, again, it uses policies. So it's just a case of going in and just changing what that looks like. Really easy. And also remember that there is no one size fits all. So we try and make it as versatile as we can. And these are some of the ideas and concepts we've come up with to help out. But there is no one size fits all. So you will maybe need to do a bit of configuration of your WAN connectivity. You may also need to do a bit of tweaking on traffic shaping if you're using it. But there's certainly a lot you can do to turn this into something that there is versatile. So yeah, I think we're just about a page where we're going to do a bit of a Q&A. If anybody's got any questions on any of that, anyone wants to ask me anything about this, then yeah, feel free.
Thanks a lot, Michael. That was a really good overview. I think that just gave us an insight into how we can use SD-WAN, what it actually does for us, and then how to start thinking about implementing it as well.
Yeah.
Yeah, like Michael said, there's an opportunity now to ask any questions if you have them. So just pop those into the Q&A box if you would like to. One question I had was, I think the diagrams that you showed in this particular webinar showed cameras that are mostly just in one position, in a fixed position. Yeah. Could this SD-WAN technology be used, for example, such as drone footage or in-car cameras, that kind of thing?
Yeah, definitely. I mean, if you're going to be running things like in-car cameras and that type of thing, then I know that some people do that already, and they may use a fixed 4G router and that type of thing. With this, you've got the opportunity to then put in, as many SIMs as you could really fit, can't you? You could put in 2 or 3, and that way, a lot of people, you can't really go ahead and survey, can you? You can go, right, we're going to take the car here, so I'll go up front, I'll do a survey, find out which best SIM to use, or whatever. You can't do that. So by going in there and basically having 2 or 3 or whatever you want in terms of Fi-Fi or 4G connections, I mean, you can park that car up. It will do that survey for you, won't it? It'll actually go, okay, I'm getting this bandwidth, or I'm getting this latency or delay out of this SIM card, and then it will use the best one. So yeah. Definitely. Okay. In terms of drones, most drones have a down some kind of downstream to somebody with some kind of controller. We have done it before. We've certainly done that. It's for some biggish events, let's call it that. And usually we would consult with people and have a look at what type of devices they're using. How can we connect in there using, say, some kind of encoding as opposed to an actual camera? But yeah, we've certainly done that before.
So it sounds very versatile.
It certainly is.
Okay, I just wanted to let you know as well, like I said, this was the first webinar within this law enforcement series that we've just started. We're really keen to get your feedback if there are any other particular topics you'd like to see us cover in this quarterly series. So as you can see on the screen here at the moment, the next date for this webinar series is in June on the 29th. We're just going to pop the sign up link for that into the chat box as well, so you can sign up straight away if you wanted to. And yeah, like I say, I'll be sending out the recording of this particular webinar later today. So if you would like to reply to that email that I send, just with any ideas that you've got for topics that you'd like to see us cover, we'd be absolutely happy to listen to those ideas and take those on board, and really shape this series into being something that will be helpful to you in your everyday work. If anything in today's webinar has struck a chord and you'd like to know more about implementing SD-WAN technology in your organisation, obviously that's something Bedrock are able to help with. We would be able to set up a call with you, perhaps look at doing a workshop just to look at your specific requirements. As Michael was saying, there is no one size fits all with this technology. So speaking to experts who've implemented this a number of times could be really beneficial before sort of taking the leap and putting it into some tricky situations by yourself. So if you would like to go ahead and do that, again, you can reply to the email I'll be sending out later today. And we'll also be in touch with you over the coming weeks just to see if there's anything else that we could assist you with. So without without further ado, that is the end of the webinar today. Let me just say thank you very much for joining us today. We're really pleased to see so many of you joining, especially as it's the first one in this series. So thank you for that. And like I say, we'll be in touch to hear about your ideas for future webinars. And we look forward to seeing you then. Thank you very much, everyone.